Hello and welcome to our explorations of Pythagoras' theorem across Asian civilizations. Today, we will dive into how this fundamental mathematical principle was understood in ancient Mesopotamia and Chinese culture. Similar to Mesopotamians, the Chinese probably came upon the theorem via real-world uses in the field like astronomy, land surveying, and architecture. They may not have a formal proof in modern sense, but their rigorous mathematical techniques were grounded in actual observations. The Pythagorean theorem is called the Gogo theorem in China. In terms of cultural expression, there may be some difference between the East and the West. There's no specific term for triangle in Chinese, and Chinese people usually use Go and Gu to represent the two right angle sides. However, no matter the difference in expression method, the mathematical theorems are very similar. So many scholars are exploring the origin of the Eastern and Western cultures at the time and how they communicate with each other. In ancient China, mathematical theorems were mostly derived from life. People often came across some interesting problems, such as consider a reed in the center of a pond that is 10 chi in diameter, where chi is an ancient Chinese unit of length. The reed extends 1 chi above the water, but just touched the top of the pond when drawn to its edge. To determine the length of the reed is equivalent to find the length of the hypotenuse in the following Gogo figure. In Mesopotamia, particularly in Babylonian and Sumerian civilizations, there were mathematical texts dating back to around 2000 to 1800 BCE that demonstrated knowledge of what we now call Pythagoras theorem. One of the notable examples is the Babylonian tablet known as Plimpton 322, dating back to around 1800 BCE. Plimpton 322 contains a list of Pythagorean triples, which are a set of three integers that satisfy the equation a squared plus b squared equals to c squared, where a, b, and c are the sides of the right angle and c is hypotenuse. It's important to know that while the Babylonians and Sumerians had a practical understanding of the relationships between the sides of right angles, their approach to mathematics was mainly computational rather than theoretical like that of the ancient Greeks. The mathematical knowledge of ancient Mesopotamia was focused on solving practical problems like to trade, architecture, or the land measurement, rather than on proving abstract mathematical theorems. Unlike Mesopotamia, the evidence of the Pythagorean theorem in ancient China is largely based on document rather than archaeological excavations of stone tablets. The representative one is the 9 chapters, also called 九章算术 in Chinese, compiled during Han Dynasty from 202 BCE to 220 CE. This contains a wide range of mathematical problems and solutions, including those related to geometry. Although there may be no direct evidence of communication between ancient Mesopotamia and ancient China or other Asian civilizations, Mesopotamia and China were geographically distant and had limited direct contact in ancient times. Although there were trade routes such as the Silk Road connecting these regions, the transfer of mathematical knowledge could be limited. The existence of the theorem in both cultures indicates the possibility of independent discovery, demonstrating the universality of mathematical principles in different cultures based on practical applications and observations. That's all. Thank you for joining me on this journey through the ancient world of mathematics.